With the EB, we are known for creating very easy to use fixed-wing platforms for mapping applications and civil engineering work. What our customers have told us in the past is that other applications such as close mapping or inspection work don't have a good solution with the existing rotary wing or helicopter drones. So with the exam, we set out to create an intelligent solution that is completely tailored for this kind of applications.
We saw that the ideal inspection system would be an intelligent and easy to use drone with a front-facing camera head with multiple imagery sensors. This kind of drone would be able to capture georeference imagery in an easy and safe way. By having the camera in front, we can get really close to the structure we want to inspect. We can also point the camera straight down to inspect the roof and also straight up to inspect under the bridges.
We started by working with experienced users in the field, such as surveyors and civil engineers, examining how existing systems are used and where they fall short. We also boosted our own team by bringing in robotics researchers with experience in designing stable, intelligent rotary systems. With the knowledge we gained, we could start building a specification for a tailor-made, close mapping and inspection drone.
Since the exam is supposed to fly close to the obstacles and objects to be inspected, we needed to come up with a design that's very safe and durable. We came up with a lightweight design that is completely surrounded by a shrouding that protects all the important elements, including the body with all the electronics, the motors and propellers, and the head, especially with all the sensors that are very important for the inspection work. With this kind of all-around protection, we can be sure that the drone is not going to be damaged or damage the surfaces, the wall, and the equipment that we're going to inspect with it.
When we started the design process, everything was driven by these market needs. We considered any technical solution that might meet these tight specifications, whether it was 4, 6, 8, or even only 2 propellers, for example. We weren't bound by a particular philosophy, so long as the drone stayed lightweight and safe. We ended up honing in on a quadcopter configuration with downward-facing rotors. This allowed us to balance motor efficiency with giving inspectors the widest possible field of view.
It is this head position that led to the Exam open front design. We think it gives more flexibility to the engineer than having the payload underneath the airframe. Then we just needed to make sure that the camera head had a wide range of vertical motion to see everything above and below the drone.
For the sensor head itself, in the beginning we imagined this would be a modular component. In other words, a swappable camera that you can change depending on the imagery you need. However, when new sensors started becoming available, we realized an even better solution might be possible. An integrated sensor head that could provide still, video and thermal imagery. The main challenge was the mechanical design of the head, fitting all these components together in a logical and efficient way. We had to optimize all the camera's field of view, wherever the camera is pointing at, while still keeping the weight low.
Having all these cameras on board every time allows our customers to minimize the number of flights for a given mission. We really pushed ourselves very hard in order to create this integrated design, which is one of the most successful parts of the exam, and we call it the triple view head.
While Roman was working on the head, the R&D team started doing the first designs of all the exam. Also the shrouding, the arms, the central body, the full design of it. Once we had the general concept of it, we started looking into details. We wanted to make a really innovative design, something totally new that will just inspire people when they see it.
This gives us this curved carbon tube arm and shrouding design, which protects and encloses the propellers, the head and the body, and these carbon rod connection bars and legs, which absorb the energy of a contact, allowing the drone to stabilize and stay in the air.
We also thought about how to pick it up. So we made it easy to pick up from the waist. It's slightly slimmer, and then you can just grab it from there. It will stay totally stable and far from propellers.
I think we've created a sensor-rich platform that's intelligent, efficient, safe and lightweight, and that's really going to help our customers to achieve inspection work without requiring any piloting skills.
Thanks to the 5 vision and ultrasonic sensor units positioned all around the Exam drone, the user gets full situational awareness, which is very important when you're operating within meters of a wind turbine, a bridge, or a power line, for example.
Finally, in the exam, we made sure to include enough processing power so that we're able to respond to the evolution of our customer need in the future and implement new mission scenarios and behaviors.